MITRE unveils Hopper UAV, autonomous drone poised to revolutionize maritime surveillance. All images, credit MITRE.org, used with permission. In a recent MITRE article, the organization introduced its groundbreaking Hopper Uncrewed Aerial Vehicle, UAV, a solar-powered drone prototype developed in collaboration with the Office of Naval Research, ONR. The Hopper, engineered for maritime environments, showcases the capability to autonomously navigate vast ocean expanses, presenting potential applications in various missions, including search and rescue, monitoring illicit activities like illegal fishing, and detecting meteorological events. MITRE's Hopper UAV. MITRE engineers Dave Sheffler and Tyler Paige prepare to launch Hopper for a recent demonstration at Lake Anna State Park in Virginia. Image courtesy MITRE.org. The ONR tasked MITRE with creating a cost-effective, intelligent, and autonomous system capable of seamlessly operating across dynamic ocean environments. The result was the Hopper UAV, a product of less than 24 months of design and fabrication by MITRE engineers. Lee Mastroianni, Program Officer for Advanced Autonomous Systems at ONR, commended the MITRE team, stating, "It's been inspiring to see Hopper rapidly develop from an idea to flight-capable hardware." The MITRE team provided a wealth of insight and innovation in support of our naval objectives. Hopper made its public debut at the Office of Science and Technology Policy's American Possibilities, a White House demo day, where it was among the 8 innovations linked to national security out of 45 featured. Deputy Secretary of Defense Kathleen Hicks emphasized the importance of such autonomous systems in maintaining a competitive edge against strategic rivals like China. The Hopper's design and development involved the use of computer-aided design, CAD, and advanced simulation software, enabling rapid iteration and the utilization of low-cost manufacturing techniques such as 3D printing. The UAV incorporates small commercial solar cells on its wings, allowing it to regenerate power during flight and at rest. The MITRE-ONR collaboration extended beyond traditional boundaries by involving students from the U.S. Naval Academy. These students contributed to Hopper's design, providing valuable insights from their operations research capstone project. The resulting technology aims to augment existing maritime surveillance platforms at a fraction of the cost, reducing the need for crewed or expensive uncrewed assets. Connor Mahoney, MITRE's expeditionary group leader, highlighted the significance of Hopper's capabilities, stating, "Where normally you'd have to risk a crewed asset or an expensive uncrewed asset to maintain cognizance over a wide ocean area, Hopper can do so at a fraction of the cost, and free up those other assets." One of the standout features of Hopper is its ability to operate in swarms, covering large areas and maneuvering collectively to overcome challenges posed by ocean currents, waves, or winds. These swarms enhance maritime surveillance capabilities and can be applied to various missions, including signals monitoring, tsunami warnings, and marine life biological research. Mahoney expressed optimism about Hopper's potential impact, emphasizing the ongoing efforts to enhance its capabilities, including expanded payload capacity, longer flight durations, and shorter times between recharges. In summary, MITRE's Hopper UAV represents a significant leap forward in autonomous maritime surveillance technology, with potential implications for defense strategies and civil applications alike.